So, you wake up one day and you notice an oddly shaped hump on your hand, or maybe an oddly shaped mole, and you start asking yourself, is that cancer? So you show up to a doctor and he looks at it with his inquisitive eye, and then he takes out the scalpel. He cuts a little sample off, and then he sends it to the lab. Now, not only you had to have a cut in your hand, but you also need to wait. And when it comes to important questions like, do I have cancer? Nobody wants to wait. So is there a better way to do this? It turns out your skin is quite squishy. It's a bit like an anti-stress ball, which you might have lying around. A tumor, on the other hand, is much stiffer. A bit like a tennis ball when comparing those two. So when you compress them, you can see where healthy tissue is based on how much it squishes. In fact, I have a sponge model of our skin tissue, as the medical term is. Here on the left one, a healthy one, and here on the right one which contains a simulation of a tumor. And I'm going to need your help to be able to tell which one is the healthy one and which one is going to need an operation. Let's go to the squisher. Okay, so we're at the squishing machine, so let's get these sponges started. And there we go. Let's pause the video. Can you tell which sponge has a wooden block in it? So, coming back from our squisher, we see that when we compress the sponge, we can gain information about its elasticity. Watch. And just like this, we see that the sponge is less elastic in the center. And, just as expected, we can pull out the wooden block inside. There we go. Inside actual human skin, things are a little more complicated. For starters, we do not have these big blue squares, which help us to see how much each part compressed. Instead, everything looks roughly the same, a bit like this other side of the sponge. So in order to see inside, we use a laser-like or coherent bright light, just like I would use this lamp to shine inside the sponge. So while I'm compressing, I'm shining inside to see the structure. You can try something similar at home. If you take a very bright light and shine it through your hand, you can see the vessels inside. I always find this very fascinating. The machine which does all this is called an Optical Coherence Elastograph. It's not yet ready for the use in the hospital, but given a couple more years of research and testing, you might as well come across one the next time you need to get your skin checked. In the meanwhile, stay squishy!